Spherical lenses. Have you ever wondered why faraway objects appear close to us when we view through a binocular? What are the two transparent materials present in the binoculars that makes faraway things appear nearer when viewed through it? Or what is the thing that we use to view small things or to read text with small size? Why do we wear spectacles? What is a transparent material used in a spectacle? To know the answer about all these questions, let's understand what a lens is. Some of the common objects that we use in our daily life like spectacles, microscope, cameras are actually working with the help of lenses. Just like mirrors work on reflection of light, lenses work through refraction of light. So, a lens is a piece of transparent glass bounded by two spherical surfaces. Light rays deviate or refract when it passes through a lens. Basically, there are two types of lenses, simple lens and compound lens. Compound lens are actually made up of simple lens. This year we are going to learn about the two types of simple lenses, concave and convex lens. A lens which is thicker in the middle and thinner at the edges is known as convex lens, and a concave lens is thinner in the middle and thicker at the edges. Let's now understand more about the convex lens. What happens to light rays when it passes through a convex lens? We have already learned that lenses refract light. In a convex lens, after refraction, the light rays converges to a point on the principal focus. Hence, convex lens is also known as converging lens. We can easily understand the converging nature of convex lens through a simple activity. For this activity, let us take a magnifying glass and a dry leaf. Hold the leaf under the magnifying glass in such a way that the sun's light directly falls onto the leaf. You can observe a bright spot on the leaf. This bright spot is the point where the sun's light is converged by the magnifying glass or by the lens. It is also observed that at this point where the bright spot is created, the leaf starts burning. This happens because all the sun's light rays falling on the convex lens is converged to a smaller area on that leaf, and at that point the heat energy is getting increased. So as more and more heat energy is received at that point, its temperature gradually rises, it crosses its ignition temperature or ignition point, and it catches fire. In this activity, what you saw as a bright spot was actually the image of the sun. We have already learned that image is formed when light rays meet after reflection or after refraction. So in a convex lens, when the parallel light rays are converging to a point, at that point the image is formed. Let us now understand about a concave lens. A concave lens is thinner at the middle and thicker at the edges. When parallel beam of light rays falls on a concave lens, the rays will spread out or diverge after passing through the lens. Since the refracted rays are diverging away from one another, they do not actually meet at a point, and this lens is also known as diverging lens. The diverging rays, when produced backwards, appear to meet at a point F on the left side of the lens. Let's now understand the different parts of a spherical lens. The center point of a lens is known as its optical center. It is usually denoted by the letter O. Sometimes it can also be denoted by the letter C. The principal axis of the lens is a line passing through the optical center of the lens and perpendicular to both faces of the lens. We have understood that parallel light rays converges after refraction in a convex lens on the principal axis, and this point is the principal focus of a convex lens. As lens is a transparent material, refraction can take place from either sides. So, a lens has two foci, and the two foci of a lens are at equal distances from the optical center. Spherical lenses are formed from the part of a sphere. Hence, the center of sphere of part of which a lens is formed is called as the center of curvature of the lens. Since concave and convex lenses are formed by the combination of two parts of spheres, therefore they have two centers of curvature. Usually the letter C is used to denote the center of curvature, but we also have to understand that center of curvature is double the focal length of a lens. Hence, here we denote the center of curvature as 2f1 and 2f2. The focal length of a lens is the distance between the optical center and the principal focus of the lens. And the distance between optical center and center of curvature is called the radius of curvature, which is generally denoted by the letter R. All these parts mentioned for a convex lens is also applicable to the concave lens. It also has an optical center, principal focus, center of curvature, focal length and radius of curvature. But there is one difference between the convex lens and concave lens based on the focus. Since all the light rays actually pass through the focus of the convex lens or actually intersect after refraction, convex lens or converging lens has a real focus. In concave lens, the light rays do not actually pass through the focus of the concave lens. They appear to diverge from a point and hence concave lens has a virtual focus. In order to understand the position nature of the image formed by lenses, let's learn some rules through which light rays refract in a spherical lens. The first rule states that a ray of light parallel to the principal axis after refraction passes through the focus of a convex lens or it appears to diverge from the focus in a concave lens. If the light ray is incident through the focus, then after refraction, the light ray emerges parallelly to the principal axis. A light ray incident through the optical center goes without any refraction or any deviation. Spherical lenses find a wide variety of use in our daily life. Usually for magnifying objects we use convex lens. So it is used in cameras, spectacles, microscope, magnifying lenses, etc. In spectacles and telescopes, concave lenses are also used. As concave lenses are diverging lens, they give a wider view and hence they are used in door peepholes to view who is standing outside. That's all for this video. I hope that you have understood the content discussed in this video. If you have understood and you feel that this video is helpful, do like this video and share the video among your friends and family. Drop your comments in the comment box. Also, don't forget to subscribe the channel to get instant notifications when the videos are uploaded. You can also check various links for revising the case study and assertion reason in the description. Thank you.